In this video, we're going to raycast 3D walls in Python Tkinter. So looking at the demo here, you can see that the character is in an empty room. You can use the WASD keys to move the character around and the mouse to rotate the character. In the top left corner, we have a minimap that's a 2D tile representation of the 3D map. The gray tiles represent the walls, while the brown tiles represent the empty space. We also have a red circle, which represents the player, and the blue line represents where the player is looking. All of the yellow lines that are coming from the player represent the rays that are casted out to calculate how far away an object is from the player. The distance between the player and the object is what we're going to use to determine how big or how small the walls need to be. The starter code here creates a full screen root window for the project and also imports the math module, as we'll be using that later on. We're going to be working with two different canvases, the canvas that displays the 3D map and the canvas that displays the 2D minimap. Let's call the 3D canvas GameCanvas and create a class for it. I'll also give it a background color just to make it easier to see. Now inside of the root class, we're going to initialize, display, and then update the GameCanvas. If you run your code, it should look something like this. Now we're going to create a class for the minimap canvas, similar to how we did with the GameCanvas, but this time we're going to give it an initial width and height of 100. For most, if not all people, a 100 by 100 pixel minimap is too small, so instead we're going to make it where the minimap takes up a certain percentage of the GameCanvas. We're going to add a method called update_size to the minimap class that makes the minimap take up 1/4 or 25% of the GameCanvas. Then we'll call this method inside of the minimap class. Back inside of the root class, we're going to initialize the minimap class and pass in the GameCanvas as its parent. Then we're going to display the minimap onto the GameCanvas using the create window method. Now if you run the code, you should see your GameCanvas and the blank minimap in the top left corner of the canvas. Since we have the minimap up on the screen now, we can finally start drawing map tiles onto it. Inside of the minimap class, we're going to create a dictionary called map_walls, which map an integer to a specific wall color. 0 means there is no wall, 1 means a gray wall, and 2 means a blue wall. Next, we're going to create a 2D array called wall_map, which defines where the walls are and what color they are. I'm going to create a 10 by 10 empty room surrounded by gray walls. We're going to need the wall map's width and height later on, so we'll go ahead and store those into variables that we can reference later. Now let's add the draw_tiles method that will allow us to draw the tiles onto the minimap. We'll start it off with getting the minimap's width and height. You can use the minimap's canvas dimensions along with the wall dimensions to calculate the tile's dimensions. I stored the calculation as an attribute as well as a local variable because we'll be using it later on. Now we're going to iterate through each point on the wall map, draw a tile, and give the tile the correct color. Now we're going to call the drawTiles method inside of the drawMinimap method. And finally, we'll call the minimap's draw_minimap method at the end of the root class. So if you run your code, your wall tiles should be drawn on the minimap based on how your wall map is structured. We can now draw the player onto the minimap as a red dot. We'll start off with creating a player class and defining the player's starting position. Then we'll initialize the player class inside of the root class. To make it easier to access the player object, we'll make it an attribute inside of the minimap's init function. Being that the player's starting point is at 0, 0, the player will be drawn in the top left corner of the minimap. We really want the player to start in the middle of the map, so we'll add a method called centerPlayer to the minimap class that centers the player's XY coordinates. Then we'll call it at the end of the minimap's init function. Now we'll add the method that actually draws the player to the minimap class. At the start of the method, we'll want to delete the player if one is already drawn. Next, we'll set the player's radius, which determines the size of the player's circle. Then we'll scale the player's coordinates to the minimap's coordinates. Next, we'll calculate the player circle's coordinates and pass those into the minimap's createOval method in order to draw the circle. The last thing we have to do is call the drawPlayer method underneath the drawTiles method inside of the drawMinimap method. Now, if you run your code, you should see a red circle in the middle of your minimap. The next step is to allow the player to move relative to where they're looking. Inside the player class, we're going to add a view angle attribute, which is in radians, and a speed attribute. Now we're going to add a move forward method to the player class and pass in self and minimap as parameters. Then we're going to calculate the player's new XY coordinates. Next, we need an if statement that checks whether or not the player will collide with the wall if they move forward. We're going to do the check in a method called collides, which we'll create once we're done here. If the player won't collide with the wall, we'll update the player's coordinates with the new coordinates and redraw the player's circle on the minimap. Now we have to create the collides method that returns whether or not the past and xy coordinates are greater than or equal to 1. Remember in our wall map that 0 means no wall, while integers above it mean a wall of a specific color. Finally, we have to bind the move forward method to the W key inside of the root class. Now if you run your code, whenever you press the W key, the player should move to the right. The reason the player is moving to the right instead of up is because the movement is relative to where the player is looking. You can't see it yet, but the player is looking to the right. Now we can add the move backward, move left, and move right methods to the player class. They all have the same structure as the move forward method, just slightly different calculations. Here is the move backward method. Pay attention to the new x and new y that are calculated. The if statement can be copied and pasted from the move forward method. For the move left and move right method, we're going to calculate a strafe angle to pass into the cosine and sine instead of using the player view angle. Here is the move left method. Pay attention to how the strafe angle is calculated along with the new x and new y. And here is the move right method. Finally, we bind move forward, move left, and move right to the S, A, and D keys inside of the root class. If you run the code, you should be able to use the WASD keys to move around the map relative to where the player is looking. In order for you to know exactly where the player is looking on the minimap, we're going to draw a blue view line. We're going to add a new method to the Minimap class called drawViewLine and make scale player X and scale player Y its parameters. Next, we're going to delete the view line from the minimap if one is already drawn and set the view line's length. The view line starting point is going to be the player's position scaled down, which is why we made the player's scaled coordinates parameters. But we still have to calculate the view line's endpoint. Then we simply draw the line. Finally, we call drawViewLine at the end of drawPlayer. If you run the code, you should see a blue line drawn on top of the player circle. Now you can clearly see where the player is looking. As of right now, the player can only look to the right of the map. We can make it where the player can look around freely by simply rotating the player. Player rotation is going to be linked to the mouse movement, specifically the mouse X movement. Inside of the root class, we're going to create a variable to keep track of the mouse's last X position and bind the mouse turn method, which we'll create after this to mouse movement. Then we'll add the mouse turn method to the root class. It calculates the difference between the mouse's last X position and its current X position as delta X. Delta X is then passed into the player's rotate method, which we'll create next. The player is then redrawn and the mouse's last X position is updated. Before adding the rotate method to the player, we have to define how fast the player turns with the turn speed attribute inside of the init function. Finally, we add the rotate method to the player class. If you run the code and move the mouse left and right, the blue line should rotate also. Combine that with the WASD keys, you should be able to move around freely. The very last thing we're going to draw on the minimap are the rays. The first thing we're going to do is add a FOV attribute to the player class, along with the number of rays we want to cast out. Now we're going to add the drawRays method to the minimap class, and we're going to delete the rays that have been drawn to the minimap. Then we're going to calculate the ray step or angle increment for each ray, and then start iterating through each ray. Inside the for loop, we're going to calculate the angle for the current ray. The next step is to cast the ray forward until it hits something. So we'll set the ray's starting coordinates equal to the player's coordinates. The distance variable is what we're going to increment to cast the ray out. Max distance determines how far the ray can be casted, and the hit while variable is going to be set to true if the ray hits something while being casted. Now we're going to start a while loop that actually casts the ray out. To start, we'll move the ray forward and then calculate its new coordinates. Next, we're going to convert the ray coordinates to integers so we can change hit while to true if the ray is outside the bounds of the map. We also want to make hit while true if the current tile the ray is in is 1 or greater. Now that we know where the ray ends from the while loop, we need to scale the coordinates down to the minimap's coordinates. Next, we'll pass those coordinates into the minimap's createLine method to draw the ray onto the canvas. Finally, we call the drawRays above the drawViewLine inside of the drawPlayer method. If you run the code, you should see yellow lines or rays being casted forward from the player. Now that the minimap is done, we can finally draw the 3D walls onto the GameCanvas. Inside the GameCanvas init function, make the player an attribute. Next, add a method called update3dWorld to the GameCanvas. Delete the current 3D world that's drawn on the canvas if one exists, and call the drawThreeDWorld method, which we'll create next. Since we're raycasting again, the draw 3D world method is going to have some of the same code as the draw rays method in the Minimap class, with a few minor changes. Now that the current ray has been casted, we can start drawing the 3D world as rectangles. The first thing we have to do is correct the distance so that there's no fisheye effect. The fisheye effect can cause walls that are drawn near the edge of the screen to bend downwards. Then we determine the wall's width and height. Next, we'll calculate the wall's 2 XY coordinates so that it can be drawn. Now we draw the wall using the GameCanvas create rectangle method. The draw 3D world method is complete, so the last thing to do is call the GameCanvas update 3D world method in the right places. Call the method at the end of the root class and inside of the root's mouse turn method. Add the GameCanvas as a parameter for each of the bindings initialized in the root class, and for each of the move methods created in the player class. Then call update 3D world underneath the Minimap's draw player method. If you run the code, you should have a 3D map to explore along with the working Minimap. And that's it for this video, and thank you for watching.